Excellent. Welcome. Lesson 5 in our acids and base units. We're talking about the strength of acids and bases this unit. So what does the pH scale even really mean in the first place is what we're going to focus on for this particular lesson. So you've heard about the pH scale. It goes from 1 to 14. It represents acids on one side and bases on the other. So acid pH values are like 1 to 6. And there's usually a relatively high concentration of that hydronium or H plus ion in there, which will react to neutralize hydroxide ions. Okay, so pH 1 through 6, H plus is dominant. Okay, now the value of 7 is neutral because the amount of H pluses and OH negatives, hydroxides and hydroniums, is in balance, neutral. So it's equal concentration. So there's really none of them hanging around. It's pH 7. The other end of the pH scale, 7 through 14, or 8 through 14 really, is high concentration of hydroxide ions. So these will react with acids to produce a neutral solution. So one side acidic, 7's neutral in the middle, the other side, 8 through 14, basic. Okay. Strong acids. These are on acids that dissociate completely. So the H plus breaks off the molecule completely, and these would have a relatively low pH. 0 to 4 typically. Yeah. Now, weak acids, there's an incomplete dissociation. So this particular H plus hops off the molecule, but not all of them do it. All right. So these have a pH of 4 to 6.9 or so. Not very strong. And that's what we got. Strong bases. These dissociate completely just like strong acids do. So the hydroxide OH part completely breaks off of the other part of the molecule. And the pH would be 11 to 14, leaving the last little bit, the weak bases, incomplete dissociation. So these ones do not break off completely. And so their pH would be like, 7.1 to 11 or so. Now, how does pH value relate to the concentration of hydronium? This is how it works. Each step on the pH scale relates to the concentration in molarity. And a pH of 1 technically means 1 times 10 to the negative 1 moles, concentration of hydronium in solution, which is 0.1 molar. So the negative exponent is the pH number. So 10 to the negative 1 means a pH of 1. pH of 2 means it's 1.0 times 10 to the negative 2 concentration molarity of solution, which is technically 0.01 molarity. When you type 1.0 times 10 to the negative 2 into your calculator and press enter, it's going to give you 0.01, not 0.02. So the negative exponent tells us how far to move the decimal place when calculating concentration. So the bigger the pH number, the smaller the concentration of that particular acid is. pH of 7 is 1.0 times 10 to the negative 7th molarity, which is a very small concentration, 0.000001 molar acid. So it's a very weak acid at pH 7. Moving further, each step corresponds to a 10 times increase or decrease in the concentration of hydroxide and hydronium ions. This is because there's that 1 times 10 to the exponent that we need to work with. So I'm going to the board to do some of these practice problems. So when the pH goes from 4 to pH 5, that's going towards the more base region. So this solution is becoming more basic. And the hydroxide, since we had a one step equals 10x, so basic hydroxide concentration increases by 10x. Now, at the same time a solution becomes more basic, it becomes less acidic because you can't really have both at the same time. So the H plus concentration decreases by 10x. Now, a different solution will be a different pH change. So we have a pH change of 13 becoming 10. So this is actually becoming more acidic. It's moving towards the acidic side by 3 steps, which equals 10 to the power of 3, which equals 1,000 times. So this solution is becoming more acidic. H plus increases by 10 to the third, which equals 1,000 times. Oops, that's 100,000 times. And every time it becomes more acidic, it becomes less basic. So the hydroxide decreases by the same factor, 10 to the 3 equals 1,000 times less basic. See what else we've got to do in terms of practice here. Each question, the two pH values are being compared. How many times stronger or weaker is the pH of the solution? So remember, we count the number of steps, we raise 10 to the power of that, and that's how many times we say increases or decreases. So pH 5 to pH 3. Well, that's becoming more acidic by 2 steps equals 10 to the power of 2 equals 100 times more H plus, H3O plus. Okay, a pH of 8 to 4. Well, that's again becoming more acidic, so that's 4 steps. Well, it's equal to 10 to the power of 4, which equals 1 with, well, 4 zeros behind it. So 10,000 times more acidic. The concentration of the acid increases. So pH 10 to pH 7. Well, that's 3 steps. That equals 10 to the third equals 1 with 3 zeros behind it. 1,000 times more acidic. pH 14 to pH 7, right? I want you to see that 7 steps. I want to see you finish the rest. pH 4 to pH 3, that's 1 step. I want you to tell me how much more acidic those 2 solutions are becoming. So, to recap, pH, you got to look and see what the pH number is. That tells you the concentration. The bigger the pH number, the more concentrated the base and less concentrated the acid. The smaller the pH number, the more concentrated the acid, the less concentrated the base. And if you're talking about pH changes, which shows up all the time, you count the number of steps it changed, in which direction, more acidic or more basic, and you raise 10 to that power to tell yourself how many times more concentrated or less concentrated that solution became. And that's it for the power of pH. See you next lesson. Find my button and I'll click it off.